This lesson is over polynomials, adding and subtracting. Let's begin by talking first of all about combining terms. Now, when you're combining terms that go together, common terms I guess is another word to say it, you must focus on matching, variable, and exponent. Exactly. Let's do an example real quick. If you've got, let's say, 6p cubed plus 7p cubed y minus 6 plus 10p squared plus 13y minus 12p cubed. Let's go through this list and see which one of these go together. Well, it should be important to look at the variables and the exponents. Notice variables and exponents, they must match perfectly, variable and exponent. So we have p cubed here. We have a p cubed here. We also have a p cubed way over here. Now let's see which one of these go together. Well, this p cubed is a problem because there's a y on it right there. And that's our problem. In order for this to combine with anything, we must have both a p cubed as well as a y. Now notice something we're not focusing on, and that is the 7 and the 6. Coefficients do not matter when we're trying to combine terms that go together, and these are called individual terms, or another word for them are monomials. So, what we want to do, the only two that go together is this one right here and this one right here. 6p cubed and negative 12p cubed. Notice they have the same exact variables, just a p, and the same exact exponent, just a 3. The rest of these don't go together either. Notice that p squared is not the same as p cubed. So it has to have the exact same exponent. And this y here, this 13y, does not match this one here. The y has a p cubed with it, so these two can't go together. And this one does not have a variable, and there are none that have variables. So we would just combine the two coefficients for negative 12 and 6. And these two right here would give you negative 6p cubed. Okay, so that's a short little tutorial on combining terms. So now let's actually work a problem. Let me erase this with my big eraser. Alright. Now let's work a problem. Let's try this one here. 2p plus 8p squared parentheses minus 2p squared minus 5p. Okay. We have two binomials and they are subtracting one another. So let's begin. The first step is to remove these parentheses. Now the question is, what do we need? What kind of rule do we need to apply to be able to do that? Well, here's the rule that we can apply. Let's assume that these parentheses are having something being multiplied to them. Like, say, well, there is nothing in front, is there? So in the absence of something being multiplied, let's just put a 1 there. That will now give us something to multiply to be able to drop these parentheses. Parentheses are designed to group together. You look inside first and you decide, can I combine terms? Well, we can't. Remember, matching variables and exponents, I have the same exponent or variable but different exponents, so they don't go together. So then I have to think, well, why else would this be grouped together? And I assume that there's something being multiplied to them. So look to the front and put a 1 there. Now let's multiply through, and when you multiply by 1, it doesn't change anything. So we can write here 2p plus 8p squared, just like they are right there. It's multiplying by a positive 1. Now the other one, however, is a little bit of a different story. Let's put our 1 in front again, but now we're multiplying by a negative 1. Negative 1, when you multiply by a negative 1, what that does is change all of your signs. Alright, well, let's apply that, and let's see how that changes. Negative 1 times a positive 2p squared makes a negative 2p squared. And then a negative 1 times a negative 5p makes a positive 5p. Now let's go through and combine terms. Look for terms that go together, or monomials that match. Okay, 2p. I'm looking, I have a variable of a p and an exponent of 1. So let's look through and see if there's another match. Yes, right here. So let's match those two together. When you put those together, you get, just combine the exponent, or the coefficients. 2 and 5 make 7p. It's not p squared. I know there's two p's, but we're not multiplying. We are adding these two together. So that makes a 7p. Now that leaves us with these two here. P squared, they go together, but notice, positive 8, negative 2, combine those together, so you'd subtract the 8 from the 2, giving you a positive 6p squared. Now, can I do any more? P squared, they do not go together, so I am left with that as my final solution. Alright, let's try a little bigger problem, not any more difficult, just bigger. Let's consider this problem. Notice I've got a binomial, subtracting from a binomial, adding to a binomial. Again, process is the same. Let's first combine terms. Drop parentheses. And we drop parentheses by adding a 1, or multiplying by a 1 in each of the parentheses. So what we would have is positive 1 doesn't change the values. Negative 1 change the signs. Positive 1 again. Okay. Now let's go through and see what terms go together and what terms do not go together. Well, we've got a P, and a P. So let's combine those, and we do that by adding the coefficients. 2, 5, and then a 1. We can put a 1 in front of there. So 1, 5, 6, 7, 8. So we have 8p. And then let's check these. P squared, oh, and p squared. So now we add those coefficients. Positive 8, negative 2 gives me a 6. Another negative 2 gives me a 4. So positive 4p squared. Now notice, p and p squared don't go together, so that is our final answer. Okay, combining terms. You must remember to match variable and exponent. Variable and exponent must be the same in all cases. And then you just add or subtract or whatever to the coefficients. Okay, that concludes the discussion on polynomials, adding and subtracting.